again. I think we're ready to get started with our webinar. So again, welcome everyone to our webinar on 2D and 3D file formats for technical illustration and data exchange. Before we get started, just the brief, let me go through our housekeeping rules for the webinar. All attendees will be muted for the duration of the webinar. If you should experience any technical issues, please use the chat window to communicate with us. We do have some handout of information available in the handout section of the webinar control panel. We invite you to drag and drop those to your desktop at any time during the webinar. You can post questions at any time during the webinar using the control panel, but the questions will be answered following the main presentation. So, but feel free to post those as you think of them, and then we'll answer those at the end. If we shouldn't get to all the questions, we'll be sure and follow up by email with you. For those of you who aren't familiar with Larson Software Technology, we're based in Houston, Texas. We were founded in 1984. We're graphics technology experts, which we've been doing that for over 30 years. But with open standards. We've promoted the CGM usage from the very beginning, initially by providing a free CGM viewer, which was recently replaced with a subscription version that we make available on our Larson online store. We were also the developer of the first HTML5 CGM viewer, which eliminated the need for plugins and it makes CGM accessible in any browser like Chrome or Edge or Firefox and virtually any platform. We're a member of the CGM Open Foundation, which maintains the CGM standard and looks after it. Our products, our technology simplifies the graphic workflow for technical publication professionals. So with that introduction said, I'm now going to turn it over to David Mennick for the presentation on 2D and 3D file formats.
Thank you, Don. Good morning, good afternoon, and good evening. Thanks for joining us today. This is our first webinar of 2022. And we're a bit rusty, and I actually didn't attach the PDFs, the data sheets for some of the software we're showing today to the webinar control panel. So I apologize for that. We will make sure they are attached to a follow-up email. So, and you can request those from us by email as well. So apologies for that. So just to give you a rundown the agenda, we'll first give you an overview to the formats that we're going to cover today, both 3D and 2D file formats, and look at the key ones. When we say key, these are the key ones that we see. They might not be for you, so we're open to feedback and in suggestions. If we don't cover formats that you're interested in, then we can always do follow-ups. So we'll begin with 2D. We'll give you an overview of that. We'll look at both raster and vector data. We'll do some demos, so some live demos of some of our solutions, our software solutions. We'll talk about the file formats in more detail. Again, both 2D and we'll be looking at 3D as well, and we'll have demos for both. At the end, we'll do a summary and a Q&A session. So if you have any questions, please post them as we go in the panel, and then we can cover them at the end. So without further ado, I'll get going. So just as an introduction, in the past, we've mainly focused on the 2D formats, and that's something we're well established in, kind of a leading supplier of CGM technology. And in the recent past, SVG technology as well. We've done a lot of work around SVG, as you'll hear about during the webinar. And in say last year, or just the year before that, we started to look at 3D. As the market seemed to be growing, we felt it was something we needed to get hold of and start developing some solutions that customers were asking us for. So that's given us a really good overview of the 3D market and also the 3D viewing market and 3D solutions in general. And there are a lot of solutions out there, but not that many for technical illustration. And obviously file formats play a core part of that. So we'll discuss later on what 3D file formats we're looking at and ones that we already support. So with going back to 2D, you would mainly find raster and vector formats. So we'll cover those in more detail. With 3D, there are so many file formats available. There's no way we could cover those in one webinar. It's just, there's too many. So we'll focus on the few that we feel are important to the technical illustration market. We'll position those formats to begin with where we feel they fit in the whole overall production process, and we'll do a more in-depth analysis of the formats plus some live demos. So these are some of the key formats we'll cover today. These are open formats. So when we say open, they're not kind of tied to any particular organization or company. So things like GLTF, we'll look at 3D, PDF in general as a 2D format, SVG, JPEG, CGM, TIFF. So yeah, you probably heard of most of these, I would assume. But we'll just position these in a second just to see where they actually fit in the overall process. So I've split this into three kind of neat sections. There's probably more than this, but I've just tried to keep it simplified. So we'd start off with source. So there'd be source data where we, as a technical illustration production, would be looking to get data from. So this could be like a 3D CAD system, or it could be legacy data, archive data of, say, raster data or vector data that we have to work on and revise. Then go over to creation and archive. So if we've imported that data, we need to work on it, revise it, and then pass it through finally to display. So I've got some file formats positioned in these different areas. So things like TIFF, SVG, CGM. There's probably ones more important to you as well, like PDF, Adobe Illustrator. I can go on and on, native formats for CAD, CATIA, and things like that. But what we try to do is keep it open formats, something that's not proprietary to one particular organization. So that should give us great interoperability. So PDF, we've really only included in display here. But PDF is an important format. It's because it's now open, like the others, which I don't think everybody realizes that because of Adobe. But it is an open format which is published. So beginning with the raster, there's still plenty of raster files out there, mainly because of archives of illustrations that have been done in the past, and also saved into raster because of that seemed to be the best way of doing it at the time. So, but these still kind of need to be maintained. So we need a way of editing those and adding vectors to them, perhaps. And it's still used as actually a display format. So JPEGs, TIFFs are still used in delivering information to the end user. So, and that's not because of, that's really because of our legacy solutions as well, software solutions, say for electronic spare parts catalogs, like say in the automotive industry, where they have systems that are still based on raster for viewing graphics with overlays for interactivity. So these are still important formats. Vector is not kind of taken over. And we see this a lot in automotive, especially. But I think TIFF and JPEG are the main formats that we come across for either actually revising or delivering information in the future. There's obviously others like PNG and GIF and so forth, but TIFF and JPEG seem to be the primary ones that which we'll talk about today, but also that are used. Now, I don't say vector data because I think it's more important that these files are hybrid because they can contain both vector and raster data in the same file, and it's editable. So CGM, SVG, and PDF are all capable of this. So why is that important? Because you might have legacy data that you want to maintain and add vectors to it, or you might want to annotate it using a vector-based tool. So containing that information in a hybrid environment is important. So CGM is a well-established format. I nearly said old because it is old. It's been around a long time, but it's used a lot still in aerospace and defense, and also commercial aerospace as well as their primary format. And that's because it was hybrid, but it could also contain metadata as well, say for interactive graphics. SVG is kind of a newer thing, although in saying that, it's been around quite a while as well. And it's one where it's over the last probably 5 years has become more widely used, and one we support in all our software now. The key thing for SVG is that it's native, a native file format to HTML5. So that's really useful if you want to view it in a web environment. So it has been around a while. You can look up a lot of information about it. It was kind of based on other markup languages from Microsoft and a bit around PostScript. And the interesting thing is, and we'll look at that a bit later, is it's an XML format. So that has its good points and bad points, which we'll talk about. Then finally, we got PDF. So PDF can actually contain both as well. But I say within our industry, it's not as widely used as a data exchange format or an archive format. It's really used for display purposes. But interestingly, there's also 3D PDF as well, which we'll discuss briefly as well, which has its limitations unless you have kind of bespoke solutions to actually deliver it. So just 2D to begin with. So we're going to look primarily at CGM and SVG and their commonality. What do they have in common? And we're definitely going to focus on these going forward. So they're both open formats. They're accredited by the W3C. So they're not proprietary to any particular company. And I think they're particularly suitable for technical illustrations. They can be hybrid, as I spoke about before, and they also have the potential to be validated. So what that means is if you're an industry that has certain guidelines or rules, then they can be validated against a set of rules or a profile, so each file is consistent and interoperable. SVG, not as much, but it does have that potential because of its XML background. So it would need some kind of business rule or profile or schema to check it was valid. And as of yet, there isn't really nothing that can do that. So we have a different strategy, and we'll talk about that as we go along for SVG. As I said, metadata can be contained in both files, which is important if you've got interactive graphics. So SVG has the same kind of capability there. And obviously, SVG is native to HTML5, whereas CGM isn't. So we developed some technology, which Don mentioned in the beginning, is where we have Visitors View HTML5 that does allow you to view CGMs without a plugin. So I spoke about XML. So there's some for SVG. So here's an example, and we'll open another example live as well. So it is XML. So there's good points and bad points to that. The benefits are it's based on an open international standard, and in theory it could be validated if somebody creates something to like a check-in tool. The main caveat is it's a huge specification. It's enormous. It has a lot of things in there, and not everything is suitable for technical illustration. So there is no real profile or rules to how you write a SVG or export an SVG or save it. So there could be problems if you want to actually write one out and then bring it back in and work on it, or if you take it to a display, take it to the web. Certain things might not work because the environment you're using to display it doesn't understand what it's showing. So we've done some work around how we would solve that, and I'll talk about it pretty much now. So what we did is we developed a profile for SVG called TECH SVG, which we feel contains the important elements for technical illustration, and we write them in a consistent way. So that means we can round trip an SVG in our own environment. So the primary kind of conversion scenario we have at the moment is people still have CGMs, but they then export them to SVG, but they're mainly used to display the graphics because of the native ability of SVG in HTML5. But we also found that we had a lot of customers using Illustrator and things like that. So we've done a lot of work to actually improve the filter, support the Adobe Illustrator files, and obviously, as I said before, be able to round trip our own files at least, so we could use them more effectively as an archive file. So SVG is an interesting format. The only kind of downside that I see for it really is that being text-based, the file sizes can be bigger. So depending on the actual illustration. So CGM kind of wins out on file size, but we're trying to optimize that to make display quicker. So where are they used? Mainly in aerospace and defense. This also applies to the raster files as well. So sometimes they might not be any better. They're also using in automotive, and oil and gas still uses the CGM format. And the reason why these industries are using it, because they're usually specification driven. In other words, it's usually written in to a standard or a spec. So again, interoperability is the key, and they're not relying on one piece of software which might disappear in the future. So companies can easily migrate their data to another solution. And CGM is especially used in S1000D. It's still their primary format. It's still it's written into the specification. But what we've found is that the SVG is now used more widely because people convert it, or companies convert it to a display, to use it as a display format because of that native HTML5 ability. Okay, so enough talking. Let's do a bit of a demo. So I'm going to just bring up, this is off a software VisX edit. And I have so we spoke about raster data. So this is a TIFF file. So this might be typical of a file that comes in from a legacy archive that we still need to maintain and edit. So TIFF does seem to be the primary format, although we've seen JPEGs as well. But if you wanted black and white monochrome, then TIFF was definitely the format. So how do we edit this? So in here, if we double click, we get the ability to bring up, we could choose the application. So this could be Photoshop or whatever image entity you've got. And I can just edit this with, say, Paint, which is obviously the simplest thing. So say I just want to remove one of these numbers, I would just use the tools, obviously dependent on the software that I'm using. Could be Photoshop. Save that, and let's close that down. And hopefully that will have updated over here on our illustration. So now we could actually add in vectors and so forth. So I have a library here, so I could just drag a vector onto this. So if I needed to add an additional part or begin annotating, I could do at this point. So we feel it's important that you have the ability to maintain all these files. We did have the idea of building in an image editor, but it doesn't seem to serve any purpose when we can actually easily go to one of our favorite image editors and then do the modification and then bring it back straight away, as you can see there. So here we see the raster format. So this could be a JPEG as well. Now we have a typical kind of exploded view. So this time we have a vector illustration. This has got some technique on it. By the way, I'm not going to do full-on demos today. This is really about the file formats. So this has got metadata, as we spoke about before, associated with it. You should be able to see that if I just put the binoculars on, and we'll see where areas have been hotspotted. So these areas have got hotspots associated with them. And if I get the annotation tool, I could actually add my own detail down here. So right at the bottom, sorry if you can't see this, but the editor number 5. And if I do to modify, I can see the information I could add to this. So when I say metadata, this means it's not a vector line or a part of the illustration. It's something that's contained in the file that might say, give me a screen tip. So I could add in whatever that is. And it could have a URL. It could link me to something else entirely, another illustration or a portion of text. So that's what we have when we talk about metadata. So once I have this, what I need to do is take it in a format that supports all these things we spoke about earlier. So if I save as, this is already doing as SVG, so let's, in fact, I actually saved one earlier. So this could be SVG or CGM, or if I needed a raster, then I could do. But the difficulty then is I would have no hotspot information. So I'd have to write that out in a separate file, all that hotspot information. But I'm just going to stick with SVG. I'm going to overwrite the one that's already there. Okay, and that should have gone to my desktop. So let me just find it. It's actually on my other screen. Just for this. So I'm going to open it up and just drag it over here. Okay, so now when I hover over these, we can see the hotspots. So this is the SVG. There's no actual plugin or anything like that, and all the hotspots are there. They don't have links to them, but you can see this one did have a tooltip associated with it. Okay, so this just shows you how you could take the file. It could begin as a raster, or it could be just a vector, and we can bring it in to we can bring it into, this is just Edge, so it could be Chrome, it could be any real browser that we have. Okay, so let's just move on. I'm just going to move that over out of the way. So this was VisX Edit, by the way. So I think I've just got a window encroaching over here. I'll just drag over. Okay, let's go back to the slides. So the next thing I'm going to show is some other examples of viewing SVG and CGM, so with a bit more kind of real world use. So let's drag those over from the window. Let's This is now Chrome I'm going to go to. Okay. So this is an SVG file. So one of the strengths of SVG is it could be data driven. So this is actually driven by a spreadsheet. So as I move around, it can be interactive, but it's giving me feedback. And you see the percentages change. And actually the legend up there changes as well. So that's a strength of SVG, that it has that ability to have that data-driven side. And so it's used a lot in dashboards and things like that. The other good thing about it is it can actually have animation as well. So it has the vectors, but we also can animate those vectors. So that with this pull down, there's actually different, you'll see that it changes, so that it rotates around that central part. And this is the code. There's actually some JavaScript behind here. So we can update the number of teeth on here. So the reason I gave you the slide is that it's got a link. So you could always go to these links and see how these are created, if you wish. So that's SVG. We now go to CGM. So this is using our VisXview HTML5 technology. So again, this is a CGM file where we've put it alongside some HTML data. So here you can see the hotspots, the metadata, give us a link back to the table. And this works in the opposite direction as well. So if I click on number 3, you'll see that it highlights number 3. So spare parts illustration, no plugin. So we have this SDK where you can just create toolboxes and so forth. So you could create this in your own environment. So as I said, hovers over, gives you that feedback. The other example we have here is, again, is a CGM file, slightly different toolbox. So you could introduce your own toolbox. And this has what we call a companion file. So CGM can have XML companion files, and we could easily switch between those to give us different information. So if we hover over here, we have the assembly. So we have kind of English, and then we could say, I now want to look at the German companion file. We move over and we see the translation. So this just gives you some ideas what we can do with these formats. So CGM has some kind of XML elements to it as well, but through a companion file. But the key thing is we have an open format, vector and raster, and we can begin to do these things with it for the end user. Okay, so let's move that out of the way. So we're going to move on to 3D, and something we've learned a lot over the past 2 to 3 years on 3D. We think the market is growing in technical illustration. Although there's been solutions out there for some time, we feel now that the file formats and so forth are a lot lighter. The solutions are there to actually create viewing environments for technical illustration. And it's not going to take over from 2D because there's so much legacy out there. But in certain cases and use cases, then 3D really makes sense. I think it can be split really neatly into 2 different use cases, though. There's the source data, where we originate the data from, but probably a CAD system, and we can convert it to 2D. So this obviously brings forward, we kind of got an overlap here. So we have 3D and 2D data. And then we have an export the 3D data from our, say, technical illustration software, retain the attributes, but add value to it that's useful for an end user. So we can bring the data in, we export it to 2D, or we retain the 3D and reuse it in a manual in some way. So with 3D, there's both open and there's native formats. And obviously open is not owned by anybody. So that we always think that's the best way to go. but there's a lot of native formats in 3D, and they're all owned. So you can use them, but you must remember that if you go down that route, then they're probably only applicable to people who have that software. So we think open is always the safe choice for data exchange, but also for displaying the data and so forth as well. So what formats are we talking about? In the CAD world, there's some major formats that are open, and STEP, IGES, JT, and there's others as well, but those have been our main focus anyway, and more so STEP. And in the future, we'll be looking to support the JT format, which is mainly found in automotive, from our experience anyway at the moment. They're all data rich, so all the geometry we need comes through, and that's if we're actually using them as 3D data or converting them to 2D. So that's important if we want to create quality 2D illustrations. There are obviously native formats from the major CAD vendors like SolidWorks and CATIA, Creo, and so forth, PTC. But we'd always advise against using those in an environment where delivering information to the customer, because it will really tie them into one particular solution. So how do we repurpose 3D data? And why do we need software to do that? Because some of these CAD systems do it effectively as well. And we're not kind of saying that is you shouldn't do it. What we're saying is we're giving you a solution to do it probably more effectively. But certainly CAD systems are capable of a lot of functionality. Converting to 2D though and to CGM, you might not get the best results. So we'd always recommend, as I said, using formats that are applicable to our industry. And certainly adding interactivity and annotations and so forth, they're not going to be straightforward in a CAD system. So how does that relate to file formats then? We go back and we export them as STEP or IGES or one of those other formats to get them into a system where we can manipulate them effectively. And we feel the illustrator actually benefits from that, and the organization as a whole, because we become more productive. And I'll show you some of this functionality soon. In fact, it's now. Okay, so let me. So this is our Vizex Edit 3D software. We have the ability to bring in, as I said, STEP and IGES files. So just getting back to file formats a second, we can import IGES, STEP, VRML, and the GLTF format, which we'll talk a bit more about in a sec. And as I said, we are looking to add at this time JT to this list as well. I've already imported a STEP file. You might notice we also can open and save. What that means is that it was very difficult to come up with a method of saving what we've done in 3D in an IGES or a STEP file. So we created our own 3D format called VX3D, which means if we change the state of this, then we can retain that state and reopen it and carry on working on it, which is obviously very important. Okay, so we have those two options. So with the model, I can begin to move it around and zoom in and all things you would expect from kind of a 3D viewing environment. And it's pretty quick how we move these things around. If I click on a particular component here, it will highlight in the tree. So we can see these aren't named correctly, but you'll see that there's a component here. And overall, it's part of the subassembly, which is the turbo. So now I've highlighted all that particular subassembly. If I right click, I can then isolate this into its own window. So this might be, as an illustrator, this might be the only bit I need to work with. So I'm just going to pull up some tools. As I said, this is not going to be a full demo, so yeah, I might be going a bit quick. But here we've got some functionality that allows us to get the view that we want. So I might want it to be an isometric view, and then I might want to kind of just flip through the different views before I get the one that I'm looking for. At this point, now I want to export, sorry, at this point I want to explode it. We'll explode it in a second. I'm going to choose the manual option, and then I can just pull this along the axis and explode the parts out. As I said, I'm not going to do too much on this. We get the idea. Okay. So we started with a step file, and now I'm going to export as a CGM file. So I'm just going to change this name. I'm going to go to Turbo. I'm going to go to the desktop, and we'll save it. So this is going to create as a 2D version of this file. I've got some settings here. I'm not going to go into these at the moment, but basically the CGM is usually pretty standard about the defaults. The others we've got down here are mainly about the 3D, which we'll look at shortly. But this is our 2D setting for CGM. Somebody might say, well, what about SVG? Well, we can always, once we got it into the editor, we can change the file format. So let's say we'll export this out. It takes a couple of seconds just to do that because it's calculating all the lines it needs to be removed. But it's usually fairly quick, and it should have gone to my desktop. Okay, we're done. I'll go back to VisX Edit, and I'll open that file up. So let's just find our desktop, Turbo, and here we are. So there's our Turbo file, the explosion I've just done. We could then annotate this up. So put the annotations on and so forth, tidy it up if we need any extraneous lines that needs removed. And then I can, as I said, we can actually save this as an SVG file. So I'm going to put it to desktop again, save it. And I'll just find that. Just bear with me a second. Got a lot of windows open at the moment. And it should be over here somewhere. Oops. Where are I? Apologies for this. And doesn't seem to want to work. I don't know why. So what I was going to show you at this point is this is the output of the SVG as in the XML world. So the key thing is that with this is the hotspots, which are down at the bottom here. So this is all how the file is created, or the graphics are created. But you can see here that this is where the metadata resides in the SVG. So what we decided to do with TECH SVG is write these out in a standard way that viewers would be able to understand it, so the hotspots would actually work. So that was important. I don't know why that didn't actually come through. So anyway, so let's get back to the slides. It is as usual demo as hit us. So displaying the 3D data. So there's again a multitude of formats. So as opposed to kind of importing, we're now exporting to use the information that we've created in the 3D world. So we're not talking about 3D to 2D anymore. We're actually now adding value to a 3D file. So say the one we just created with the explosion, we might now want to see that in a 3D viewer. So it wouldn't be something we'd show in the actual illustration software. We need to see it independently of that. So we've been looking at formats to support for 3D, viewing 3D models in browsers. So some of the considerations we looked at is it native to the browser? So do we need to have a plugin? What's the file size? Can it contain metadata like hotspots, like the 2D files? And a very specific one, does it support placarding of text? So in other words, text always remains facing you. So we looked at various formats and kind of assessed those. So things like we initially looked at, say, X3D, because the world we live in from an industry point of view, likes XML. So X3D is an XML format for 3D files. But we found that was quite heavy, took a long time to display, and create really big file sizes. We looked at VRML, which is actually, X3D is like the ongoing, it's like the next up version of VRML. And VRML has been used for quite a while to deliver information in 3D, but we found it not to be kind of quite, not as modern, quite old. So we decided to keep looking, and we actually in the end found GLTF, which is a really light format, and I'll talk about in more detail in a second. We also looked at 3D PDF as well, but that seems to be more specific for delivering the whole of the PDF rather than integrating it with other things. So you might have to just deliver a 3D PDF with all the information that you need for the customer. So you kind of limited in that way, whereas GLTF could be embedded into different browsers. So a lot easier for integration with text and things like that, or data that you might need other than that's not in the PDF. So we decided to support GLTF as our primary 3D format. And we look back now and we think it was really a good decision, mainly because it's been really easy to work with. It's very light. There's no plugin required. And Microsoft and Adobe both use it extensively. So they chose that for our file format as well. So that should give us really good interoperability with other software. So we can export as a GLTF, or GLB it's the same file, but it's actually a binary file, as GLTF tends to be a bit larger, but GLB is a much lighter format, and it's one we kind of favor. So as well as something to author the data, as I was showing earlier, to actually explode the model, the end user is going to need a way of viewing it. So as I said, it is HTML5 format, so you could view it natively, but that really doesn't give you some of the controls you might need for zooming in, zooming out, like with a toolbar. So we created a GLTF viewer, which would enable people to actually build in some functionality that would be useful for the end user. So we really created our own technology around it, called VisX View 3D. So it's not kind of a standalone piece of software. It's more of a development kit, so you could use it within your own, say, IETM interactive technical manual. So this is the final demo. Just need to be able to find it, because we had quite a few today. Apologies, a lot of windows moving around. So this is the viewer. This is the file I showed the engine. So we have a toolbar, the model tree on our left-hand side, So we can highlight parts and so forth. We should be able to actually find the turbo in here as well. So similar to what I did before. So now we're in the viewer environment. So here I'm just in Chrome. This is the toolbar we've created using VisX View 3D. And I can choose different views on here. So we might just want to see orthographic views and so forth. And these can be customized. And we could also do isometric views as well, straight from the control bar. So if it was, although it's native, if you brought it straight in, you would not have all these controls. So that's quite important. Okay, so that's just the model. I might even be able to, no, I don't think I can bring, I don't think I saved it anywhere. So I was going to bring in the model I just exploded. But we also have an example of a kind of a more real life example of where you might use this. So perhaps you have a 3D spare parts catalog. So if we move over this, I don't, you can see we have like a tooltip. And and similar to before, this works in both ways as we did with the CGM. So I move over here and it's highlighting it on the right. So this is just a prototype we created. So you can see we have interactivity this time in the 3D world. And I can move over this side and click and I can highlight. So the body on here, I can click and highlight the different things. So this should be really useful for the user. And plus, you could add other things to this. So we have the description, but you might have a shopping basket if somebody wants to kind of order this part and so forth. We also have a drop down here where you could have different views of the same model in this window. So it's just replacing this one over here. And we have the similar functionality to what we have before. Okay. I don't know why it's taking so long. So I can get the view that we want. And obviously this still works. The table obviously updates on this side as well. So this was just a prototype. It's not kind of real world, but it gives you more of a real world feel. So what we could do with a 3D file, and this is a GLTF file. So we found this gives us all the functionality that we need, a light file, but one that can contain metadata as well as we did with the 2D file. So didn't want to dive too much into our technology, but hopefully gives you an idea of what you probably need to do if you chose a different file format. You might have to build an environment to view these things. So let's just go back to the slides. And we'll just summarize. So apologies for all the kind of Windows switching and so forth. I hope it wasn't that too confusing. But we looked today at both 2D and 3D data exchange. We think the best solution is always open. So not a file not owned by a particular company or organization. Selecting your display formats is pretty crucial because at the end of the day, the user's got to use these to actually do their job. So with 2D, obviously there's more solutions out there for creating IETMs and things like that. And a lot of them use CGM and SVG already. 3D, not as much so. So that's why we've done that research around using, say, the GLTF format for viewing 3D files. And we've made that easy for the user to actually create the GLTF and add in interactivity and so forth, and then build out in the browser, as you've just seen as an example, something more real life. Our 3D and 2D strategy is really to develop productive software, things that make your life easier, and also use file formats that you can interchange with your or existing solutions, or work with your CAD department and so forth, so you can bring this data through and begin to use it. We're always working on these solutions, so new functionality will be coming soon to both of them. In particular, with Edit 3D at the moment, we have a new function that we're going to introduce very soon, which will make it even easier to work with step files that come through. So we'll preview that in a later webinar, or we'll obviously put that on our LinkedIn account and so forth, so people can link to it with a video. So hopefully you enjoyed it today. Obviously we're biased in some of our things that we're saying with file formats, but we have done a lot of research, and hopefully you'll benefit, our customers will benefit from that. So at this point, if you have any questions, hopefully in some ways we've already answered them because of what we've been talking about today. But if you want to ask any questions, please do so now. I think Don's been monitoring those, so let's just see what we have. I just have to get my... Don, can you rejoin us perhaps?
Yes, I'm here.
So what do you have in terms of validation of customer provided graphic assets? My situation is that I have CGM files that are being used to produce PDF. My PDF generator is throwing errors on some of the CGMs. That's quite a technical question, Don. Perhaps you want to... Can you comment? You probably can't comment it too deeply without seeing the CGM, perhaps.
Yeah, well, there's, you know, I guess, yeah, there are tools for actually validating CGMs and validating them against certain profiles, because there can be certain things, for instance, that are valid in an ATA profile that are not valid in the S1000D. So some of those depend on which profile, which is obviously dictated by the market or the customer industry. So I'd say there are tools to validate. Some of our tools, we try to make our tools for editing and viewing these forgiving, so that you can usually deal with them, even though they may be minor problems. But I guess that's one of the things about CGM versus SVG, is SVG being XML encoding does allow it to be, you know, validated by XML encoding, you know, because it's XML encoding. So, but yeah, that can be challenging sometimes, working with files, especially if they're legacy files too, and they're old, and sometimes before some of these rules for CGM were even set up, some of these files were created. So you have to deal with issues that were worked out in the system, but you have to deal with the legacy files. So
yeah, in some ways this is a slightly different question, because this is an error thrown up by PDF when it creates a PDF. So that
yeah,
you know, so you might validate the file, but it still might give you an error when you export to PDF. So it's probably something in the file that PDF does not like, rather than the CGM being invalid. So we'd be quite, if you want to, if it's possible, if you want to send us the CGM file, we can analyze it for you and see what we see from our side, what might be causing the error. It might not affect the file in any way when it goes into the PDF, the display of the file. So it might just be something that PDF doesn't like, but it doesn't actually affect the display of the file in any way. So my suggestion is, if it's possible, send us a CGM file. You know, we've been working with this format for many, many years. So if anybody can find out what's wrong with it or what's causing the error, I think we can. So I would say that's the best answer to that question. With the 3D, sorry, another question. Will your 3D editor support the creation of animation. We get the same question pretty much every time we show the software, and it is something that's on our roadmap to support animation. It's not as straightforward as you might think, or you might not think it's straightforward even. But for our own strategy on that is we have to create a tool that's really easy to use. Not that you need, we can't be saying you can't use complicated tools, but we need it to be very productive. So very easy to create timelines and things like that. Our hesitation is that there's a lot of software already out there that does animation of 3D files. So our kind of requirement is very specific, and you could get a very complex piece of software that does animation, but it would take so long to learn it. It probably defeats the object in some way. So I suppose the answer is yes, we will be doing it. It's on the roadmap, but we have done some work on it where we prototyped it, but there's still a lot of work to do yet before we'd have something that we can put into, say, version 2 of Visx Edit 3D. So I suppose the answer is yes, but it's not there yet.
Yeah, one thing I could add to that, Dave, is that we do support animation in our 3D viewer. So so we already got that part of the equation, where we support animations in our viewer. So
yeah, but they would have to be created somewhere else, wouldn't they?
Sure, right.
Yeah, but yeah, it is something we are intending to do. So we're looking for step animation. So yeah, this is a where you have a procedural, say in a maintenance environment, you have a procedural procedure you have to go through to, say, disassemble something or maintain something. So that is exactly what I was saying, that we have to be very specific in how we create this to make that really easy, because with a 3D illustration, if you have a spare parts, it's already exploded, so it's kind of already done. Whereas we see animation being applicable to disassemblies or assemblies, or repair, disassemble it to repair something or maintain something. So it's a different type of illustration, and it might be associated with different steps. So you might have step 1 when you clicked and it does the animation. You step 2 and you click and it creates does it again. And so we have to kind of take account of that, and then make it easy for you to interpret that within your viewing environment. So that's really why we don't want to rush into it, because we could easily create something that animates, I think, very quickly, but it wouldn't be very user-friendly, and it wouldn't match the requirements for, say, a procedure. So again, the answer is yes, but we're still working on that at the moment. So I've just got another question. Sorry, I have to go away from my microphone. Can you add hotspot links to GLTF that has animation? Kind of the same answer. So we have 2 different environments where we have the viewer and we have the authoring environment. It is possible to add links to the GLTF, isn't it, Don? So you could link from one thing, like a hyperlink.
Yes, that's correct. Actually, in your like in your demo of that landing gear demo, we're connecting the graphic
exactly
to the HTML in that the bill of materials on the right, and the graphic. So yes, you can get events from the when you use your mouses over on the graphic window, they can be received and linked to the table, like in this case. So yes, and then you can put links in the 3D file too. They can be encoded in there.
Yeah. So yeah, you're exactly right. So this, when I hover over the graphic here, you can see the tooltip, and so this actually is linking to the table. So this could also link if you think about it on the right hand side, there could be a procedure. So you click on the procedure, and then the 3D graphic either animates or displays the next in its exploded state. We were actually thinking of doing something like that, where you'd have a procedure on the right. So we can't animate at the moment, but we could go to its disassembled state, perhaps, just to show you that you can link between the two, between the procedural steps and the 3D graphic. So the answer is yes. We do have metadata, but we're not. It could easily link to an animation, yeah, as well. But we can't create the animation in our own Physics Edit 3D yet. But if the animation's already done, then yes, it would play back in here in the viewing environment. So please remember, you've got two different things going on. We have the viewer and we have the authoring tool. So really good questions, thank you. I think this is our last one. So what other formats will you support in the future? So that's a good place to end, because it gets us back to file formats again. Is that I think I did mention during the presentation that we will support, definitely support, I think now JT, because it looks a really good format, a lighter format than STEP, and it's widely used in automotive. So I think that is something we'll definitely do in the future. Other ones that we thought we'd get asked for, like native formats, haven't really come up yet from a user base, and seem to be quite well covered with STEP, especially where certainly CAD departments are quite happy to provide those, because usually they would actually create them anyway. But if we can support native if we need to, because there's technology which we can introduce to support, say, a native CATIA. But in saying that, I think most CAD departments will be pleased to hand over, say, a STEP file, as long as it doesn't affect what they're doing. Okay, so again, the answer was yes, we will support other file formats in the future. So thank you very much for attending. Probably we've overrun a bit, but hopefully you've enjoyed it. I apologize again. If things were confusing, please send us an email. Post webinar, we'll be happy to answer it. And also I'll make sure that some of the technologies today, you can either find them on our website, cgmlarson.com, or I will also attach them to the mailer that goes out with a recording and so forth. So thanks for attending today. Stay safe out there, and we'll obviously speak again soon. Thank you.